Hello, Mike Hoffman here again. I'm going to talk about renewables integration issues, particularly with reference to the Pacific Northwest. There have been a number of news stories relative to wind integration here in the Pacific Northwest in the last month. Well, actually several years, but particularly in the last couple of months. Stories such as the heat wave about a month ago that demonstrated the limitations to wind power, i.e. wind generation not necessarily being concurrent with weather events. That's something that's fairly widely known here in the region, whether it's summer or winter. Also, the idea that BPA is raising its wind integration rates relative to what it charges independent power producers, wind farms, to take their wind into the system and distribute it around the region, solidify it, and deliver it at another point in time by using the hydro system as a backup, a battery basically, for storing that energy when the wind blows, shutting the dams down or reducing their output. So that's been an issue here in the region. And then there's also been BPA's installation of a number of wind anemometers here in the region recently to help forecast winds. And those anemometers are part of a set of recommendations that were put together a couple of years ago in a wind integration study that was done by the Northwest Power Planning Council. BPA, other utilities in the regions were very involved in that. I actually helped create an appendix for technologies to help integrate wind that was at the end of that study. And one of the cheapest ways of integrating wind was to do better forecasting, potentially. There's a number of other options within that study that could be considered. Relative to wind, you could build more transmission, which is very expensive. You could use energy storage in the form of batteries, or actually pumped hydro storage, which is an option which is the most capital intensive up front, but the least average cost long term. You could also use gas turbines to firm up wind. And the reason for firming wind is that when the wind's blowing, you need to be able to, if it suddenly stops, to bring up power immediately. The hydro system can do this pretty easily, but depending on the season, river flows, fish constraints, that may not be easy, and there's now getting to be a lot more wind in the region than the transmission operators had expected or potentially wished to deal with. Because of that within our variability, they schedule wind, and if it doesn't come on, they have to make immediate changes. So firming it up is an interesting proposition and task. The idea, though, I think, of using gas turbines, which particularly at night you'd run a gas turbine so that you could ramp it up or turn it off, doesn't make environmental sense or economic sense. And that's one of the next steps that I've heard regional players talking about. I think actually the pump storage is also being talked about. That's a longer term solution. I think it's probably one of the better ones. And then there's also demand response, which is basically turning on and off air conditioners or heaters, such as baseboard heaters or heat pumps in the winter, or air conditioners or heat pumps in the summer when they're in air conditioning mode, hot water heaters, other devices, dimming lighting, that's demand response. The systems that can do that, either residentially or commercially, can also provide energy efficiency savings relative to one internet gateway allows the house to have access to the data of what wind is doing, and the house could actually dial back in for wind to be transported across the Cascades when there's a capacity constraint on those systems. So it probably shows I'm kind of a demand response energy efficiency combination person. Because of the ability to put it in at fairly low cost. It's really smart grid, it's responsive and flexible potentially. It does require a lot of homes and businesses adopt it, and that requires touching a lot of customers versus being able to put gas turbines or big dams in for pumped hydro. Utilities have one project to deal with rather than millions of projects across the region. But the question is, in the long run, do we want centralized energy sources or do we want distributed energy sources? And the demand response efficiency brings benefits to end users, both residential and commercial and even industrial, that allows them to save money, respond to the market, and basically enables end users to participate in the smart grid, whereas the larger projects don't. So that's my talk for today on the 25th of August 2009, and I'll talk more about integration and renewables in the region in the future.